Good morning, folks. It is Marathon Stream Saturday. Goal is to get a ton of stuff done today. I've got about an hour right now before breakfast. I figure that we're going to just get a couple quick things done now, and we're going to sort of plan out everything for the day. And then after that, I take a quick breakfast, and then I'm back all the way until 5 p.m. And then we'll see if I do more in the evening. I have some other work to catch up on then, but we're going to get a good, long, uninterrupted stream in today. So there are a couple things I want to do. First of all, I think we're just going to fix the RMS norm thing that was missing from C++. We're going to add that real quick right now. And then we're going to try to come up with a plan for the main thing I want to do today, which is to add a C native vectorization backend to PufferLib. And really, there are only a couple things I don't know how to do. And funny enough, it revolves around like types, because we need to have the same vectorization work for all the different ends. That's not too hard. But then also we need some way to configure the various ends from config params, and that's a little sketchy in C. But we'll figure it out. Flip the screen over, and we will get all. Oh, and we also need to do pip install. But when is it that we can get into our little debate on how RL is flawed for robotics? Why do you want to debate me on that again? Like, I'll gladly discuss it with you. Those, like, Udowski-style debates are super cringe, though, man. I'll gladly discuss it with you publicly as well. The reason those debates are stupid is they're not actually conversations. They're for the benefit of the audience, and you're just basically talking past each other. And hello, Francesco. Like, I think you'll agree with me. Like, do you not think that we can make robotics way better if we just have fast sims, algorithms that generally do several times better on games, and let you automate hundreds or thousands of experiments immediately? Okay, so I'm not saying that we insta-solve everything in robotics. I'm saying we unblock the field, though, in the same way that I've, like, unblocked the majority of RL research outside of, like, niche, like, really domain-heavy areas, right? Like, RL research is so much easier now than it used to be, and we've made some major breakthroughs that let us do our experiments super fast, that let us solve problems, that before would take months. We can just do it instantly and automatically, right, without any fancy algorithms. Like, that same thing, you apply that to robotics, and you're going to see a massive acceleration of everything. Now, in a robotics, you have way heavier simulators, but, like, they don't all need to be as heavy as they are. You can apply the same sort of treatment. Pretty much that. For anything remotely interesting. Fast sims are not a thing right now for anything remotely interesting. Yeah, but that's because people are trolling. Like, I've gone through so many different domains, right, where people have slow sims, and I've built fast ones. You know, like, we've got our drone sim that's, like, millions of steps per second. Actually, Fiber here, FBR, has built a ton of different little robotic sims that are super fast. Sims are the problems. Building better sims? Yeah, I agree. But now, like, the RL doesn't just work when you have a fast sim. If you throw stable baselines at it or whatever, it sucks. If you throw like RL games or whatever the hell the roboticists use, I've seen some repos with that, it sucks. So like a lot of what I do in Puffer is making it easier to have fast sims and to have this like closed loop for prototyping stuff as well. I've been awake validating results. What results are you on, Fiber or FBR? Sims are not available for manipulation. Yeah, I agree. But like this was true everywhere, man. Like look, even frickin' Breakout and Pong, simple ass stuff like this, was written to be way slower than it should be. Every single env here is done from scratch in PufferLib, and every single env here is fast. Oh, you can't do driving fast. It's a hard problem. Okay, we made the second generation sim 15 times faster than it was. Now they're training at 1,000,000 steps a second. Oh, you can't do my whole PhD multi-agent 1,000-agent training. You can't make that fast. It's hard. Okay, here's a sim that runs 1.5 million steps per second per core and is now training at 7 to 800,000 per GPU, and it's going up from there in 4.0. It's like, oh, you can't do drones fast. How about 3 or 4 million steps per second? Like every single thing I've touched, it's just like bloat. There's no fundamental barrier to doing this. Yeah, okay, like fancy contact sim and stuff and robotics. Yeah, there's some, but you have a way, way heavier physics engine for the vast majority of simulations than you actually need. You do not need the same level of fidelity that you have for a humanoid when you're doing a 6 degree of freedom arm. But that's the standard. Like, there's absolutely no reason a 6 degree of freedom arm should be running at 100k steps per second or less. It's stupid. Offline RL is the way. Offline RL is, well, it's just not RL is the thing. It's supervised learning. So basically, offline RL is the way means you give up because you couldn't figure out RL. And the offline RL datasets are tiny. I saw like, oh, we have 1 billion frames of data. That's nothing. I eat 1 billion frames of data in minutes in PufferLib. Parallel time compute with an algo? But you solved parallel time compute. What's that mean? Tried MJX, got 50k SPS on GPU. Yeah, see, exactly. There's no reason it should be that way. You should be able to get better than 50k on a CPU core, single core. Easily. Easily. Generally, my approach to everything is I just assume that everyone is trolling and things can be made way better, and I'm usually right. So, I mean, you can tell me that, like, no, this specific thing just has to be slow or whatever, but, like, unless you show me, like, yes, it takes this many floating point operations, which is more than you have on your CPU or GPU, and no, you can't cut any corners, like... Well, but the thing is, you're probably right for all intents and purposes, Francesco, because I don't particularly intend to go do a bunch of robotic sims unless we suddenly get a ton of client inquiries in that area that really want dedicated work. It's like one of the interesting areas out there, but it's not the most interesting area. And humanoids are definitely not the most interesting area. Like, industry arms, in my opinion, are way more interesting than humanoids. If you mean like, if by interesting you mean like things that will actually shape the future rather than that will just shape the image of the future, right? What can I do with this measly thing I have in PufferLib? You can train most of our environments. Probably at 1 million steps per second. You can do plenty. That's the cool thing about it. You can probably still train drones to fly around in like, maybe not 30 seconds, but in 2 or 3 minutes. Okay, so for some reason these yahoos didn't add this to the C++ API. Can anybody explain to me what this parameter does in the RMS norm? The code's kind of weirdly written. Self.affine. Element-wise affine is true. Why does it make a weight? Does it use group norm? Oh no, it doesn't. I'm dumb. All spaces in time in CUDA. Wait, we simulate all spaces in time in CUDA, and then we can get 2 mil paths second, then solve the lowest energy to goal given set constraints. I have to look at what you've done. That sounds cool, though. Yeah, that would make sense that you can do that. Like, compute all paths in parallel and just see which one's better, but do it on a GPU. That'd probably be a really cool demo. Okay, so this thing does have one learnable weight. Did they just not include any of these in their, Did they just not have any normalization layers at all? A module. This is normalization. Oh, there it is. Yeah, this is just missing a layer norm, I guess, right? Novel solution that compresses all states. Approximate, you mean, right? There's no way you compress it exactly to that. I don't know exactly what you're doing. Man, you always have so many projects. Why don't you PR some stuff? Like, finish one of them and PR cool env already. The code standard is like not like crazy difficult for Puffer. You know, it's just like write brain dead simple CN and like PR cool demo and have on website. Literally, we have new programmers doing it. Like, you've done all sorts of control things as well. You get some of them onto into Puffer by now. Be a good time. I think we're gonna just do this. more simply for now because this is such a mess. Why do they write their code that way, man? It's just so gross. Novel solution to compress all states. That sounds interesting. I don't know what that is, but that sounds interesting. All right, Cerberus. Self-learning parameter count is dimension dependent. Lower dimension searches lower params, higher dimension. Self-learning for optimizers. All right, you're gonna have to like put a clear thing of what on earth you're doing here because that sounds like there could be something very cool, but I don't know precisely what you're talking about. Like what is the thing that you have done, sir? Good sir. Self-learning for optimizers. Okay, what does self-learning for optimizers mean? Yes, like what does that mean, sir? Warpad Warp Atom. What is Warp Atom? Why? Wait. You say just think about warp atom. Like I'm supposed to know a random one citation paper from 2024? Online during training at no extra compute. Okay, so you think that you have a better optimizer? Or is this like a specific meta learning thing? Do you think you have an optimizer that you can like directly test and show on a few things in Puffer? Is that it? How do they do optional params? Oh, this options thing. We'll do that after then. Well, it's none, though, to begin with. The brain that controls the optimizer. The whole meta learning thing was like adapt to new tasks or whatever, right? How the fuck is this still? How the fuck is this thing calling? I hate the torch code base so much. The fuck is this? Def RMS norm. Return RMS norm. Where the fuck is the implementation? Standard benchmarks. For sklearn. My god, nobody uses sklearn. Those benchmarks are like contested on by like real architectures. No, I need the actual freaking implementation of this. Don't I? gamma I. Oh, okay, no, so this is sum over I. Okay. So we can just do x. X times x. Wait. Something like this, right? Hey, here from X, why do you think C++ is a terrible language? I'm having to study for CUDA and Torch. Because it takes a good language, which is C, and then just arbitrarily bolts a bunch of bullshit onto it. You have a million bloody ways to do everything. You have no idea what's allocating memory. You have no idea what's fast and slow. And, like, ultimately, you just confuse the way that you do anything. So you end up with people writing shit tons of C++ code and it somehow being slow. Like, that's very hard to do in C. It's very hard to, like, write code that's slow without knowing why. So if you're going to be using a low-level language, the point of it is you want it to be fast, right? So C++, you end up with more complex code that is also somehow slow, and it's difficult to figure out why it's slow. Not to mention, you just have, like, gobs of god-awful syntax because you're bolting modern features onto C. So it really just doesn't do anything well, frankly. It has kind of no redeeming qualities other than the fact that you can ignore it and write C in it. That's pretty much it. I'm finishing this one thing, and then I get to write C for the rest of the day, which is going to be great. See you around. I will be back after breakfast anyways. I'm gonna go. I have breakfast in 25 minutes, and I'm here all day after. Marathon stream. Not figured out how to get to work in PufferLib. I've been implemented adapts the learning rate and stuff. That I did this wrong, right? Like, supposed to be. Wait, did it just like output gobs of garbage? Yes, it did. Well, this isn't getting an auto grad. Seven things it does. The optimizer. Hmm. Need these C++ traces, right? Trace. That seems fine. Takes tensor for forward. This guy. Alright. And if I can go look for a linear layer. I hate how you literally can never find the source code that you're looking for. And yeah, you can just never find the source code you're looking for ever in Torch. Okay, so its weight is register parameter. Then you do reset parameters. But this has reset in it. Supposed to just call this. What the heck is wrong with this thing, man? Oh, you dummy. Did I not? Torch tensor forward. And return this. Not get to this. I'd like to get to vectorization. Dude, how is this thing erroring? Like, how is this thing freaking erroring? On Mingru layer? Okay, 461. Is there anything else in here? Torch check fail. Full tensor. How does this thing break it? Like, why is this not letting me? It's like very odd. Plus, man. Okay, so this works. So, are we just not breakpointing somehow? Prototyping might fundamentally change the neural net. You're gonna have to, like, describe what the heck this thing is properly at some point, man. I got a quick breakfast in, like 10 minutes, and I'm gonna be back all day. Got none. That's like just massively mixture of experts, no? You're not running 100 build dense. Okay. Thing. This. Oh, you dummy. God damn it. Why is it error there, though? That's so weird that it errors, like, there. It's supposed to be eager mode. Like, bizarre. Yep, there we go, dummy. Oh, it is ones. Cool. So this is supposed to actually work now. Doesn't look super amazing yet, though. Does learn. Maybe there's some differences. Huh? Actually, that's pretty solid. Look at that. Right at the end. Yeah, that learns. That's a full solve of breakout. Boom. Full solve of breakout. Perfect. Just in time for breakfast. Ship it. This is going to be RMS norm on. No, MNIST is a very, very toy benchmark, my guy. Welcome, Fabio. I am gonna go for breakfast now. I'll be back very soon, like probably 30 minutes tops. I'm live all day today, and I'm gonna be working on the C vectorization backend. So if you are interested in that, come back, check that out. Start the Puffer on GitHub. Really, really helps us out. Discord for getting involved with dev, and everything else is on X. I will be back in half hour tops-ish.